Next topic is the radius ratio. So for various coordination numbers, so we are getting the various ratio. So in the ionic compounds, the radius of the anion is bigger in size. So the radius of the cation is smaller. So this one is the size of the anion. So the cation needs to be settled in that void. So this one is the anion. So that the coordination number for this cation is 3 because this cation is attached with the 3 anion here. So 0.1552 to 0.225 cation cation radius range only able to fit in that position. So otherwise it will not fit in that particular position. So this type of structure we are seeing in trigonal planar. So example is B2O3. For coordination number 4, so we are getting that radius range 0.225 to 0.414. The structure is tetragonal and the example is XII-NS. For coordination number 6, the radius range is 0.414 to 0.732. Structure octahedral and the example is NaCl. So for coordination number 8, that radius range is 0.732 to 1. The structure is cubic and the example cesium chloride. So next topic is imperfection in crystals. So during the formation of the crystal, some ions are missing. So it creates the defects in the crystal. So it also changes the physical and chemical properties of the crystal. So this imperfection is divided into 4 types: point defects, line defects, interstitial defects, and the volume defects. So point defects means so the ion is missing in the particular point of the crystal. So next one, line defects means so we are seeing this type of defects in the line fully. So the volume defects and the interstitial defects, it's fully based on the voids. So in this portion, we are concentrate on point defects only. So more especially in the ionic compounds, the point defects are further classified into stoichiometric defects, non-stoichiometric defects, so and the impurity defects. So the stoichiometric defects are again divided into 2 types: Scotty defect and the Frankel defect. Non-stoichiometric defect again divided into 2 types: metal excess defect and the metal deficiency defect. So first one is the Scotty defect. So in the Scotty defect, same number of cations and the anions are removed from the solid. So this one is electrolytically neutral. So the ratio is maintained here. The same number of cation and the anion is removed from the solid. So the density is changes. The density is changes. So example for this one is vanadium oxide. So the vanadium oxide, the theoretical density value is 6.5 gram per centimeter, but experimentally we are getting so 5.6 gram per centimeter. So next one is the Frankel defect. So the here cation is missing from its place, so that ion is settled in the interstitial position, that is voids, that only we are calling it as interstitial position here. So that ion is settled in the interstitial position. So that only Frankel defect. So in the Frankel defect, there is no change in the density. So next one is the metal excess defect. So metal ions are present in excess than the anions. So example for metal excess defect is NaCl, KCl and the lithium chloride. So all are alkali metals. So we are going to heating this for this metal excess defects. First, we are taking the NaCl as example. So while heating the NaCl crystal, so in the presence of sodium vapors, so the sodium ion from the sodium ion in the vapor state is going to settle on the surface of the NaCl crystal. So the Cl present in the lattice crystal comes out. The Cl present in the lattice crystal comes out and join with the NaCl present on the surface. So both are reacting and forming the NaCl crystal. See this sodium, this leaving sodium ions leaves the electron. That electron is deposited in the voids. So that place only we are call it as the F center. So F center is Farben center. So that means Farben means color, center means here center. So while we are passing that light to that, while we are passing that light towards that crystal means, so that the electron emits that light. So for example, this crystal is NaCl means, so it emits the yellow color. So for example, this crystal is a sodium chloride, lithium chloride means, so it emits the pink color. For example, if the crystal is a potassium chloride means, so it emits the yellow color. So next one is the metal deficiency defect. So for example, in the inorganic compound FeO, so the ratio of iron is less than the oxygen. So it creates the metal deficiency here. So the Fe2 plus is missing from its place. So it creates the metal deficiency. So the missing Fe2 plus is balanced by twice the number of the Fe3 plus here. So the Fe2 plus is oxidized to Fe3 plus. So oxidized means it giving electrons to this oxygen. So in FeO, the Fe is in the range 0.93 to 0.98 only. So that Fe and the O is not in the 1:1 ratio. So next one is the impurity defect. So we are adding that cadmium chloride to the AgCl. So cadmium is in the 2 plus oxidation state, but Ag is in the +1 oxidation state. So that cadmium giving the 2 electrons to the silver here. So while adding a impurity, so that cadmium replaces the silver here. So the Cd2 plus is there. So that the cadmium replaces the 2 silver Ag plus here. So and the Cd2 plus is settled in the 1 Ag plus place. So in the another place becomes empty. So that only we are call it as voids here.